Hey everyone, this is Dr. Walker. In this video, I'm going to go over an example from video 558, RC circuits charging a capacitor. In this example, we have an uncharged capacitor, 5 microfarads, and then we have a resistor, 8 times 10 to the 5 ohms. They're connected in series to a 12-volt battery. The switch is thrown to position A. So this position just tells us that we do have the R and the C and the battery, so it's a charging capacitor circuit. First, we want to find the maximum charge on the capacitor. Well, we learned in the notes that the maximum charge is given by the capacitance times the EMF. So we just have to multiply 5 times 10 to the negative 12 times 12 farads times 12 volts, and that's going to give us 60 microcoulombs. Part B, we want to know what is the maximum current in the circuit. This is another plug and chug, the maximum current, which is the initial current in the circuit, right? Because we have the most current as soon as the switch is closed. And then we have no current when the capacitor is fully charged up. So the maximum current is given by Ohm's law, E over R. We know that the maximum current is when the capacitor still has no charge on it, and the only resistance to the flow of charges is the resistor. So we're going to do 12 volts over 8 times 10 to the 5 ohms, and that's going to give us 15 microamps. That's not too bad so far. And now we want the charge and the current as functions of time. So we said that the charge as a function of time was equal to the maximum charge, which is 60 microcoulombs, and it was times 1 minus e to the negative t over RC. Let me just write the full equation, just since it might have been a little while. This was the equation that we found for the charge as a function of time, and then we just have to plug in the values. And we can calculate R times C on the side. R times C is 8 times 10 to the 5 ohms times 5 times 10 to the negative 6 farads, which actually gives us 4. And the unit for R times C, if you simplify the units, you actually end up with seconds. All right, so if you want to do the work and show it to me, you can get 1 point extra credit on the test. I just came up with that just now. If you want to show me how we know that the units do come up to be seconds when we multiply the farads times the ohms. All right, so the charge is going to be 60 microcoulombs times 1 minus e to the negative t over 4. So as long as the time is in seconds here, the units cancel out, and our charge is going to be microcoulombs, and given by this expression at any time, we can get a certain amount of charge. And then the current as a function of time, we said was equal to the maximum current times e to the negative t over RC. So just plug the numbers in. We're going to get 15 microamps. And actually, we can just put the units at the end here. It looks a little bit neater if we just do it like this. We'll put the units at the end. 15 e to the negative t over 4, and the units will be in microamps. So there we have it. We use the equations for charge and current, how they vary as a function of time for a charging capacitor in an RC circuit.